So solving linear systems of equations by addition, I call it addition here, just to kind of, because I want, that's what I want you to think of. We're going to add them together. Another way you will see it called is by elimination. That's possibly a way a math book would show it. So when both equations are in standard form, that should sound familiar. Standard form. What's true when equations are in standard form? Anybody remember what's true when our equations that have an x's and y's in them, when they're in standard form, what is true about standard form for them? For a linear equation in standard form, what's true? Oh my goodness, it's staring you right in the face on the notes. Come on. Okay, it's ax plus by equals c. Well, what's true? They're equal. What's equal? It equals c, so there's a constant on one side. C is the constant. What's on the other side? Where are the x's and y's?
ax plus b.
Are they together on the same side? Ax plus by, the x's and the y's are together on the same side, and there's a constant on the other side. That's what ax plus by equals c means. You have a number of x's plus b number of y's. They're on the same side with each other. They are equal to a constant. So when the equations are in standard form, both of them have to be. So when they are both in standard form, we get to use this process today. If their a values are opposites, what do opposites mean? Okay, so give me an example of a pair of opposites. 1 and negative 1. One's positive, the other one's negative. Okay, now what's the really technical term? What's the really technical definition of opposites? Not just that one's positive, the other one's negative.
They're different.
No, they are different. But they're also the same in some manner. Did you know that? They have the same absolute value, and absolute value means distance from 0. Good job, Julia. They are the same distance from 0. So opposites mean they are the same distance from 0. Two numbers on the number line that are the same distance from 0. They have the same absolute value. So 1 and negative 1. Give me another example. 2 and negative 2. So when they are opposites, so when the a's are either opposites or, you know what, you want to put another box around that? That's an or. Or. It doesn't have to be both of these. If the a values are opposites or their b values are opposites. So we're going to zero in on the number of x's and the number of y's. We're going to say, are either of those opposites of each other? Are the x's in one the opposite of the x's in the other? Or are the y's in one the opposite of the y's in the other? It only has to be one or the other. Well, if they are, we're going to just add them together. We're going to act like these are 3-digit numbers. So let's look at our first system we're going to solve here. 3x plus 2y equals 7. Negative 3x plus 4y equals 5. I just want us, before we even move on, I want you to tell me, would it be a lot of work to graph these, to use the graphing method for these? Why? Why would it be more work to graph them? Yeah, they're not in slope-intercept form, are they? So if they're not in slope-intercept form, we got to get them into slope-intercept form, so then we can find the slope and the y-intercept. You know, that's one of the ways for graphing. We can also make a table. That's a lot of work too. So it kind of looks like they wouldn't be very friendly for graphing. How about for the substitution method? Do they look good for the substitution method? Not really. Do either of them have an x or a y alone on the other side? No, they don't. So we have to work some, we have to get one of them renamed so that then we could substitute into the other one. So that would create a fair amount of work, right? Well then, instead I say to myself, oh, but they're both in standard form. 3x plus 2y, ax plus by equals 7 equals c. This one's in standard form, negative 3x plus 4y equals 5, ax plus by equals C. So what's the A value in the first one?
The 3.
The 3. What's the A value in the second one?
Negative.
Negative 3. Are those opposites?
Yes.
Okay, well then we don't even care about the B right now. We're just going to concentrate on the fact that the A's are opposites. So the A values are opposites. We have a 3, like you said, and a negative 3. Bingo, I love that. Because that means now we can do what? Add them together. We're just going to add them together. Okay, so we have 3x. Let's just write it again so that we don't mess around with what was there. We know what was there to begin with. We're going to add these guys together after we get them lined up. See, they line up really nicely. It's kind of like we have 327 and negative 345. Huh, isn't that cool? We're going to add them together. We're going to put a big plus sign there. When we add, we know we'd have this nice addition, bar going across the bottom there. But the really cool thing about this is we don't have to carry things like we do when we add 3-digit numbers. We don't have to start at the right and carry. All we're going to do is say, you know what, column by column, we're just going to add them together. 3x plus negative 3x. What's that?
0.
Okay, let's just cancel them out then, okay? They're gone. What's 2y plus 4y?
6y.
6y. And 7 plus 5? 12. Okay, let's bring that 6y down, and what are we going to do? Divide by 6. Y equals 2. Isn't that meaningless? Would have been a lot more work to get that in slope-intercept form and then graph it and or even substitution. They would have been a lot more work. Look at how easy we made that because they were in standard form and they had opposite A values. Now what are we going to do? Well, this is where you might have to work a little harder. Well, you do have to work a little harder. You're going to have to take that y value now, and you're going to have to find x. So we need to find x yet. Let's put that. We need to find x. We know that y equals 2. How are we going to find x?
By substituting.
Now we're going to, substitute into, does it matter which equation do you think? No, because they're working together. These guys are pals. Doesn't matter which one. So you pick which one you like better. You know, do you want to work with the one that has the negative in it, or do you want to work with the one that has all the positives? Me too. Okay, so we're going to do 3x plus what?
2y
Equals,
7.
okay, let's go ahead and substitute our y value into it. And you know how to do this, so go ahead. You finish, I'll finish. We'll see if we get the same answer, okay? What'd you get?
1.
There you go. That means I'm right. Woo-hoo. Hey, what's our answer? What's our final answer?
1, 2.
1, 2. Ordered pair 1, 2. Even though we solve for the y first, it's not first in our ordered pair, is it? No. So ordered pair 1, 2. Do you like it? Me too. Any questions? Okay, let's go to the back then. I got some arrows there. I don't know. What do you think I got some arrows there for?
Identify objects.
Aurora?
Because you have to.
Election.
Rename them. Let's rename them, okay? Because you know, when there's no numbers involved, you're kind of like, maybe it'd be best if we could have some numbers involved over here for like, so what is our A value in that first one? 1. So we really have a 1x plus a 1y, and that 8 doesn't need to be renamed. In the second equation, what's our A value? 1, so we have a 1x. Let's change it to add the opposite, okay? Let's do that, plus a negative y. What's our B value?
-1.
-1. and that equals negative 18. We have opposite A values?
No.
Are 1 and 1 opposites? No. The B values are opposites this time, aren't they? So the 1 and the negative 1. Remember, it doesn't matter which one is. Whichever one is, we're going to say, oh, that's good. Now I can set this up and add it. So I'm going to take 1x plus 1y equals 8, and 1x plus negative 1y equals negative 18, and I'm going to set up my addition problem.
So does that mean like that the C's can be opposites too?
The what?
The C's.
No, the C's don't ever have to be opposites. No. Only the A's or B's. We want one of them to be opposites. So when we add the x's together, do they cancel each other out?
No.
No, because they're not opposites. 1x plus 1x is 2x. When we add the y's together, do they cancel each other out?
Yes.
Yes, because they're opposites. So we just bring down our equal sign, and 8 plus negative 18.
Negative 10.
Negative 10, okay. Go ahead and finish solving that for x. I got negative 5 for x. Anybody want to agree with me? Yeah? Okay. Go ahead, you decide which equation you want to use to solve for y, and you don't even have to use the renamed one. You can go back to the original. Get y equals 15. Anybody use the other equation? Just because I just want to see if curiosity we still get the same thing. Would we get the same thing if we use the other equation?
Yes.
We better, yeah. So what's our final answer?
13. Negative 13.
Negative 5, 13. These two equations would intersect on the graph at order pair negative 5, 13. Okay. Any questions? Okay, I want us to rename the next one, and then after we rename it, I'm gonna let you go to work solve. So, we really only need to rename the first one because it has subtraction in it. So let's rename it as 4x what?
Plus negative 2y.
Yeah, plus negative 2y equals 2. Do we need to rename the second one? No. Clarence?
Could it also be negative 2y equals 2 plus 4?
So you want to know if you could rewrite it negative 2y plus 4x equals 2.
No. Negative 2y equals 4x plus 2.
No, it would be, if you want to do that, and I'm not really sure why you want to, but if you want to do that, it'd be negative 2y equals 2 minus 4x, or negative 4x plus 2. I think you want to do it, yeah. You're kind of like rearranging them. We don't want to rearrange them because they're in standard form, and we like that for this method that we're learning today. Okay, after we'll be cool. We'll come over here and add them together. Oh, wait a minute. Before I make that decision, I should ask myself: Are the A's opposites?
No.
No.
It's
4 and 3 are those opposites? No. How about the B's?
Yes.
Okay. Well, if the B's are opposites. When the A's aren't, then that's a good deal. We can go ahead and do our adding. Okay. Go ahead and solve this problem, please. 2, did you get that? I think we all should have solved for x first. Okay, volunteer to go up and get the y for us. You're done, and you're just sitting there. You what? You volunteer to do it? Okay, go do it. Use the white space over there on the left, and show us getting your y. See if we all agree. Use your finger because the pen is, I don't know why. Just use your finger. It's a magic. It's magic at right.
I'm a wizard. You used the same one as Noah did, the 3x plus 2y equals 12. Did you get y equals 3? It's right here, like he did, right here. Did you get y equals 3? Then you used the same one as Noah did. If you didn't, you should have. Okay, so if you can't, you didn't figure out where you disagree with him. Those of you who used 4x minus 2y equals 2, did you get y equals 3? Anybody get y equals 3 when you use the other equation? We have to, yeah, we have to. So if you didn't, we gotta find your mistake. Okay? So let's do that one then. So we did actually have a couple of people who did not get the answer they were supposed to for y when they used the other equation. So let's change this to add the opposite, right? So we have 4x plus negative, I want to replace that x, don't I? We knew what x was. Okay, so we know that x is 2, and it's y that we don't know. Okay, so what's this become? 8. Okay, what are we going to do next? We need to subtract 8. Okay, so take 8 away. Now what? It's negative 2y equals what? Negative 2y equals negative 6. What's going to be our last step? Divide by negative 2. We have to divide by negative 2, so we're going to take negative 2y and divide it by negative 2. We're going to take negative 6 and divide it by negative 2. What's a negative divided by a negative? A positive.
How many 2's are there in 6?
3.
Okay, so we get y equals 3 between the other one, 2. So we have to get the same answer, don't we? And the final answer is ordered pair, as Noah says right here, 2, 3. Ordered pair 2, 3. Okay. Don't you like this? Okay, let's get busy on your homework then. You have 6 problems to do from the book. Anyone can't see that over there? Need me to write it on the front board?